Welcome to all the Atma Electrocrats subscribers. Myself, Chandrasekhar P, working as an assistant professor in the Department of Electronics and Communication, ATMI College of Engineering. Today, we are going to see the another experiment, that is amplitude modulation and demodulation for a given standard amplitude modulation and an DSB-SC, which comes under a communication laboratory of a 4 semester as per V2 syllabus. So before going to the experiment, just we briefly see the introduction of this communication, that is communication laboratory of a amplitude modulation experiment. So when we come for a communication is nothing but it is an exchange of information between the one point to another point through a proper channel or a medium. That medium, it can be an air or vacuum or a cables like etc. When we come for a communication, there are two types of a communication. So based upon the signal, that is baseband communication and then carrier communication. In baseband communication, the message signal is transmitted without any modification, and the term baseband signal is used for original message signal generated from the source. The best example for baseband communication system is an telephony system. And the second type of communication is a carrier communication. The communication which uses the modulation to shift the frequency spectra of the message signal is known as a carrier communication. So for the frequency shifting, the high frequency carrier signals are used. The carrier signal does not carry an information but helps in carrying a message signal which acts like an envelope. In carrier modulation, we have got three basic properties of the carriers like amplitude, frequency or the phase, which is going to change according to the message or a baseband signal. Then we comes with an amplitude modulation. So amplitude modulation is the technique in which the amplitude of the carrier signal is changed according to a message signal m of t. So the message signal is called as an m of t and the carrier signal is called as an c of t. So depending upon the frequency spectra of the modulated signal, the amplitude modulation can be classified into four categories. One is double side band suppressed carrier, which is shortly called as a DSB-SC, and another is double side band with a carrier like an amplitude modulation, single sideband modulation. Next, fourth one, VSB, vesistical sideband modulation. In this video, we are going to see the explain of an DSBSC and a demonstration of a DSBSD and its modulation and demodulation process is going to be explained. In DSB-SC modulation, the bandwidth of the modulation signal is 2 times the modulating signal, and since no discrete carrier signal is seen or sent after the modulation, this type of modulation is what we call as a double side band suppressed carrier. This experiment, that is amplitude modulation and DSB-SC signals modulations, are going to be carried out by using an IC 1496. Here is a pin configuration of an IC 1496 where it has gotten a 14 pins, where in that 7, 11, 9 are called as a no connections, and 12 pin is an output pin, and the 10th pin is an carrier out, and 8 pin is an input carrier. And the signal input or an input what we are going to feed into a pin number 4 with a biasing pin of N5, and we are going to obtain the output. Either you can get a output from N6 or an A12. So this is a circuit diagram of an AM as well as the double, that is SB-SC. First, the circuit is connected as per in the circuit diagram shown in a figure. Switch on the plus 12 volts of a VCC supply from the power supply and apply sinusoidal signal of an 1 kilohertz, which is called as an amplitude 1, and amplitude 2 week to week as a modulated signal, and the carrier signal of the frequency 11 kilohertz and amplitude is of an a 50, which is 15 volt peak to peak for a carrier frequency. Now slowly increase the amplitude of the a modulating signal, which is m of t up to a 7 volt, and note down the maximum value modulation value and the minimum modulation values. Next, calculate the a modulation index using an equation and repeat the step 5 by varying the frequency for the modulating signal. Finally, we obtain the values. By keeping those values, we are going to plot the graph frequency by a modulation index versus amplitude and frequency. And another graph we are going to draw with respect to the modulation index versus amplitude and frequency. And the value of the resistor for this experiment is going to be calculated by using the F value and the C value, where C value is taken as a 0.01 microfarad and F value is considered as an 3 kilohertz. So by using this information or by using this data, we can calculate what is the resistor value. So this is an output of the amplitude modulation. You can see over here there is no in an output. This is an output signal, this is the carrier signal, and this is the message. When this message signal or carrier signals are bombard each other or are combined or mixed with each other, your final output will look like this. That is an amplitude modulation. The procedure for a DSB-SC is like this. Connect the circuit diagram as shown in a previous diagram. The carrier signal is of an 1 volt peak to peak in amplitude and a frequency of 83 kilohertz is applied as a carrier to the pin number 10. An AF signal of 0.5 volts peak to peak amplitude and a frequency of 5 kilohertz is given as an input signal to the pin number 1. Observe the DSB-SC waveform at the pin number 12. So this is a sample pitch of the how the output is going to be obtained for an DSB-SC. Next, we'll move on to the hands-on session.